So, today we're getting into talking about the volume and the surface area of prisms. Now, first off, when it comes to our volume and surface area is the amount of two-dimensional space taken up by all the faces of the solid. Imagine you were making the shape out of cardboard or out of plastic or out of whatever material you want. The surface area would account for the amount of material that you need in order to make that specific shape. Now, when it comes to our shapes, you're going to deal with bases and lateral faces. The bases are what the shape is named after. On a prism, there's two bases, the bottom and the top, which, keep in mind, are not always on top and bottom. Sometimes they can be on the side, because you can rotate shapes. But the parallelograms in between, or any of the faces that are not bases within a shape, those make up what's known as the lateral area, because those are lateral faces. Now, if you're trying to fill the shape with something and measure the amount of three-dimensional shape that you can fill it with, that's volume. Another key term that you've seen in this class, but is one that we haven't truly defined, is known as an altitude, also known as solid height. In the three-dimensional world, you measure, and it's not always solid height for altitude, it's three-dimensional height. But in the three-dimensional world, when you're measuring the distance, in prisms, it would go from base to base. In pyramids, it would go from base to top vertex. If you have a shape that is in any way slanted, they call it altitude to kind of make that difference in recognizing that it's not necessarily going to go as directly across as you would think. Altitude must be perpendicular to the base of a shape. Just like when you dealt with two-dimensional shapes, height and base had to be perpendicular to one another. The height and the base of three-dimensional shapes also has to be perpendicular. The other thing that you have to pay attention to when it comes to this unit is the altitude. The height of a shape is not the same as necessarily the height of its base. Because oftentimes when you deal with certain shapes, if you're trying to find the area of, say, one side of the shape, for example, this is a triangular prism, you want to find the height of the triangle. Height of the triangle goes from here to here. Height of the solid goes from base to base. So you have to be careful. When it comes to three-dimensional figures, we are going to deal with different heights. Okay, so to get a little bit more practice of what we were doing yesterday and also kind of bringing in some important things, we are going to label the prism, label its altitude, shade one base and outline the second base on these prisms, because this is a key thing to being able to do anything with prisms, is knowing what the bases are, knowing what the height is, and knowing what the shape's name is. Hint, these are all prisms. What's the name of the base of this prism? What shape is both congruent and parallel in this picture? What shape shows up twice? Trapezoid. So this is a trapezoidal prism. This is one of my bases. The other base being back here. And you could technically outline them both rather than shade them both in. The key thing you need to know is that those are the bases. We also want to label the height of the shape, the altitude. In a prism, distance from base to base perpendicularly is the height. Here's a line going from base to base. Does that appear to be perpendicular to the bases? Does it appear to form a right angle with the bases? Yes. I'm not trying to trick you. That's the height. Okay. Second one. What shape is that? Triangular prism. Its bases are triangles. One base, two base. Height of said prism. On prisms, it's distance from base to base. I see this line going from base to base. Does it appear to be perpendicular? If so, that's the height. Notes packets up there. We are on page 5. Okay. Next one. Because I'm hearing a lot from the same people, I'm going to my name cards. Vivian, what is the name of this prism? Close. It's 5-sided. Starts with a P. Pentagonal prism. The pentagons are the bases. There's one. There's the other. Going from base to base, I notice this distance. Does that appear to be perpendicular to the bases? Yes, which makes that the height. Problem D. Aiden, what type of prism is D? It is a rectangular prism. Which sides are the bases? Top and bottom, left and right, front and back. The rectangular prism, it could be any of them. I generally, if I can, like to do top and bottom as bases. Does it matter? No. Connecting base to base is this line. Is that perpendicular? Yes. Connor. E. Oops, I forgot to write this. What shape is E? It does have a rectangle involved, but are the rectangles parallel and congruent, or are the triangles parallel and congruent? Then it's a triangular prism. Prisms will often have a bunch of rectangles on them. The triangles are the bases. Distance from triangle to triangle would be the height. That could be the height. By the way, is that the only distance that could be labeled as the height? Or are there more places I could have labeled the height? There are more. This could have been the height. This could have been the height. And that's the same on any of these. I could have labeled that or that or that or that as the height. As long as it's perpendicular, any of those can be the height.
Was that a right angle in that triangle?
That's a right triangular prism, yes.
Okay, so they purposely wrote that right angle?
Yes.
Okay.
Yes, that base of that prism is a right triangle specifically. Okay, last one. Haley, what's this one? What kind of prism? Yes, hexagonal prism. Six-sided bases are hexagons. Is this perpendicular? Yes. You're not always going to see the right angle in the prisms to get their true height. Sometimes you just kind of have to look at the shape and be like, okay, is that going directly to them or is it slanted? If it's slanted, it's not right. Now, the key thing about this really is we're actually trying to get to our surface area and our volume of our prisms. Now, the fun thing about prisms is that regardless of the shape of the prism, regardless of its base shape, if it stands straight up and down, which the ones that we're going to deal with do, even if they're on their side, the key thing is they're not slanted. When you unfold them to look at surface area and lateral area, you get a bunch of similar shapes. These are three different prisms. Regardless of which of the prisms it is, these two on top and bottom are my bases, and then all of these are the same shape. They are all rectangles. If it's a slanted prism, they would all be parallelograms, but isn't a rectangle a parallelogram? So, that means that if I want to find surface area and if I want to find lateral area, the rectangles make up the lateral area. Now, when I unfold these shapes, okay, so my recording cut out, so I'm doing a little bit of re-recording. That's why it probably looks kind of weird right now. So we left off at working with trying to find our lateral area and our surface area and our volume formulas specifically. Oh, come out. Don't mind me, I'm working with manipulatives and trying to get them to come out. There we go. Now when it comes to our prisms, first off, lateral area is essentially the area when you take away the bases of the shape. So if I've got this rectangular prism here, and let's say, actually it's technically a square prism, but if I look at this prism and I unfold it to look at the different sides, these two small squares are the bases, and therefore these four rectangles make up the lateral area. And that works with any of our shapes. Say I have a pentagonal prism here. It unfolds into a bunch of rectangles that make up the lateral area and the two bases, the two pentagons. Now, if you want to find the lateral area, you're essentially finding the area of a big rectangle. Now, I'm going to use this because it's smaller and it fits on screen better. But you're just focusing in on this area for lateral area. Since it's a big rectangle, rectangles are parallelograms, so it's base times height. This base, if I fold the shape back up, ends up going around the base, and the distance around a shape is its perimeter. So this length is the perimeter of the base. Now, the height of this rectangle, when I put it back together, is the distance from base to base along the shape, which distance from base to base, from one corner of the base to the other corner of the base, that is the height of the prism, the true height of the prism. Therefore, you want to find the lateral area of the shape. You are doing perimeter of base times height of prism. Now, keep in mind, capital letter means you cannot find it by just looking at the picture. You have to actually calculate the perimeter of the base. The h is lowercase because the height of the prism, while sometimes you might have to calculate what it is for various reasons, most of the time it's just going to be given to you on the picture. Actually, I think all the time. Yeah, all the time. Okay, now, surface area, there's two formulas for surface area. Those are capital S. And surface area just takes into account all the sides. So not only the lateral area, but the bases as well. On a prism, regardless of what type of prism it is, there are two congruent bases. Therefore, the surface area is two bases plus the lateral area. Or, more commonly, we're going to use this formula. Two bases plus the perimeter times the height. Essentially plugging this formula in. In fact, I'm not going to use that formula. If you want to ignore that formula, you can. Now, these are both areas, which means when it comes to their units, they're going to have units to the second power. In other words, units squared. Because that's what areas do. Oh, B, by the way, is base area. Remember, capital letter means it's something you would have to calculate about the shape. You can't just look at the shape and know what that is. Now, volume, it's harder to kind of show you. But the volume essentially is if you've got your shape, like here I've got a plastic pentagonal prism. Look up the top on it. Volume would be the amount of liquid it would take to fill this shape up. Its formula is base area times height of prism. And since it's a three-dimensional measurement, it is units cubed, or to the third power. So, to do this process, we have to work in pieces. You gotta be willing to go through and do a little bit of a process. The first thing you should do, if you were trying to find the volume and the surface area of a shape, is recognize what shape it is. This right here, since I see two congruent and parallel triangles, here and here, that makes this a triangular prism. Now the triangular part tells me the base. The prism part tells me that the formula I'm going to use, or formulas for each volume and surface area, are the formulas that we just wrote down. So those are my formulas that I'm going to end up using, but I can't go to them first because I don't have capital B or capital P, and nor have I identified H. To get these things, first off, to get B and P for these formulas, I have to look at the base. So what I do is I say, okay, I'm going to look at the base. The base was the triangle. I'm going to draw the triangle outside the shape, make it easier to look at. About this triangle, I know that that length is 5, that length is 6. I know that from here to here on the triangle, which I'm going to do as a dotted line, is 4. This length, remember the triangles are congruent, so this triangle and this triangle are going to be the same. If this is 5, that means this is 5. Once I have those marked, I focus in only on the base. I ignore anything to do with anything else. I just want to focus in on this triangle, nothing more. Now when I focus in on this triangle, I need to find capital B, which is the base area, and capital P, which is base perimeter. So those are what I'm going to look for regarding this base. Now here's where having your formula sheet is going to be helpful. So grab out that formula sheet if you don't have it. Mine seems to have disappeared. So, blank formula sheet for me it is. Thankfully I know the formulas. Now, to know which formulas to use, you'll notice that I am on the side that we used from chapter 11. That is on purpose, because right now I'm working with a triangle, a two-dimensional shape. It is not working with a three-dimensional shape currently. So I'm looking at my two-dimensional side. Triangle, area formula. I'm gonna move my iPad to the side for a little bit. Is 1/2 base times height. And the perimeter was add up all three sides. So, since this is a triangle, that's the formulas I'm using. This A corresponds with this B, this capital A and that capital B, because they're both trying to give me the area of a triangle. Now you have to be careful when it comes to these shapes. You have to be careful in the sense that this H over here and this H right here are not the same thing. This H is height of prism because it comes from the prism formulas. While this H is the height of the triangle because it comes from the triangle formula. It's two different heights that we have to look at. So, base and height of triangles are perpendicular, so it's 1/2 times, here's my right angle, base of triangle is 6. Height of triangle is 4, because those are what are perpendicular. Calculate that, you'll find that the base area is 12. I don't put units on at this point, I put units on the final answers. Perimeter says add up all the sides. Make sure you're only adding up the side lengths, not the 4, that's not a side length. So perimeter 5 plus 5 plus 6 is 16. Once I've calculated both capital B and capital P, now I go back to looking at the bigger picture. I ignore this triangle. Now, I'm not going to actually cross it off when I do it, but I just don't pay attention to it anymore. Now, to do these formulas, I need B, I need P, I need H of prism. So this part I still need. Height of a prism connects from one base to the other base. So, find a base, find a corner. Connect that corner to the corner of the other base. That length would be a height. I don't know that length though. Different corner. Connect to the corner of the other shape. Struggle bus. That length would be a height. I don't know that one. Different corner. Connect to the other one. Hey, I know this one. That is the height of my prism. All three of these are going to be the same length. So you just have to find one that goes from one shape to the other. On different prisms, there's going to be more of them. But it has to go from corner of one base to the corner of the other base, and it has to be perpendicular to it. Now that I know that, I have everything I need to plug into my formula. 2b is 2 times b, and b we calculated to be 12. Plus p, we calculated to be 16. Times h of prism, we just found to be 7. that is calculator friendly. You can type the entire thing in, or you can do it in pieces, but make sure you're following PEMDAS. If you're doing it in pieces, you're doing 2 times 12, you're doing 16 times 7, and then you are adding them together. But 2 times 12 plus 16 times 7 will give you the exact same result. That is the surface area, given that it is an area. The units, which in this case are meters, are going to be squared. Volume, similar idea. Capital B we found to be 12. Height of the prism we said was 7, which is 84. Volumes are meters to the 3rd power, or meters cubed is what we call it. Every one of our shapes, sorry, let me try that again. Every one of our prisms, regardless of which type of prism it is, triangular prism, rectangular prism, hexagonal prism, pentagonal prism. Note I've got these filled out because those were done. Like this one here is a rectangular prism. And we're going to go through how to find it. That's already done as a part of the other video. But if it is a prism, the formula to find its surface area and to find its volume is the same, regardless of which type of prism it is. The prism piece tells you to use this formula and this formula. The rectangle piece tells you your base is a rectangle, and that's how you get your capital B and your capital P. Funny thing about rectangular prisms is oftentimes any of the sides can be the base. You got to make a choice. Which one are you going to call the base? Top and bottom, left and right, or front and back? Or top and bottom first. You need to know which side you're making the bases on a rectangular prism, because if you do not know which sides are the bases, then you're going to have issues with the heights. Okay, my base is the rectangle. Looks something like this. About that rectangle, I know that this is 11, this is 10, and therefore this is 11 and this is 10. How do you find the perimeter of a shape again? Add up all the sides. 10 plus 11 plus 10 plus 11. Perimeter's 42. Base area. I look at my formulas and I remind myself to find the area of a rectangle. Rectangle fits underneath what general shape? Because rectangle's not on our pink sheet directly. Is it?
Why do you have the right angle on there? If it's on all 4 sides.
Because I was too lazy to draw all 4 of them. And it was pure laziness. Okay. Do I use the triangle formula? No. Do I use the parallelogram formula? Is the rectangle a parallelogram? Yeah. So that's the formula I'm going to use. Lowercase b times lowercase h, but are these h's the same?
No.
No. In base area, this is height specific to the rectangle. In the prism formula, this is the height of the overall prism specifically. 2 different h's. Okay, what is the base of the rectangle?
That could be any.
True. Pick one.
11.
Sure. Which would make the height what? 10. This is what we're looking at. We're not looking at the prism right now. Base area is 110. So, S equals 2 times B, we just calculated to be 110, plus P, we just calculated to be 42, times H. Is this height of rectangle or height of prism? Prism. Which means I'm not looking for it to be the same as this 10. I'm looking at my shape and saying the height of the prism is what? The 5. Not pretty, but very calculator friendly. If you're going to do it in pieces, then you need to do the multiply and the multiply before you do the add. Otherwise, you can do all of it in your calculator at once. Your calculator knows order of operations, provided you don't have one of the little ones that's not scientific. 430. What units go on a surface area? Feet squared. Volume equals capital B, which we calculated to be 110, times height of prism, which we said was 5. 550. Ava, what units will go on that? Feet cubed. Okay. The back's got just a couple more examples. We are not doing the work backwards problems. We did the first example. That's what I wanted you to stay for. If you need to go now, go. Sorry, my bad. Okay. We're going to do these two. These two we're actually doing tomorrow. We're getting back to these two tomorrow. Okay. Jocelyn, what shape is C? Triangular prism. Being a prism means we've got this formula and we've got this formula where that H is specifically for the prism. If on your formulas you want to change that H to be H with prism right after it, it's not a bad thing. Okay, after I establish that, I've been doing what math first? What have I been drawing? The base. In this problem, my bases are the triangles, so it's that one and that one. So that's what I'm going to draw. Do you notice there's this right angle here? Colin pointed it out earlier when we saw the problem like this one before.
Yeah, go Colin.
So, I'm going to draw that as a right triangle. Cam, what's a measurement you know about this right triangle? Sorry, you said height. I did not hear you properly. Where is that? What number going where?
4.
4 where? Top, left, or angled?
Wherever.
No, not wherever. It's got a specific place.
Top.
Goes on the top. Isabel, what other measurement do we know about the triangle? Do we know that one or that one? The straight, the vertical, okay, the vertical one. What number? Perfect. They're technically all straight. Straight was the wrong term, but you followed what I was saying. Okay. So, that's what we got. To find the perimeter of a shape, I need to add up all three sides. Do I know the third side? If you're missing something, what shape do you use to help you out? Same as last chapter. Triangles, specifically right triangles. Do we have a right triangle? Yes. On the measurement that I'm missing, I can put an X. Am I doing trig or am I doing Pythagorean theorem? Pythagorean theorem. Which side's the hypotenuse? X. So, a little more off to the side, I'm doing 3 squared plus 4 squared equals x squared. Do y'all trust my Pythagorean theorem?
No.
Well, Colin, go ahead and do it on your own. Everyone else, I'll tell you, x is 5.
Yeah, I got 5. All right.
Beautiful. So the perimeter says add up all the sides. My sides are 3 plus 4 plus 5. Assuming I can math, it's 12. Base area. What formula am I using for the base area? Hint, what shape is the base?
Triangle.
Triangle. What's the formula for the area of a triangle?
1/2 base
1/2 base
of
of triangle times height of triangle. Base and height of triangle are perpendicular. What measurements are perpendicular? Connected by right angle.
3 and 4.
3 and 4. Does it matter which one's the base and which one's the height when it's a right triangle? No. Y'all know how to multiply, you get 6. So, if you've got a right triangular prism, you might end up having to solve for something. If it's not a right triangular prism, you still could end up having to look for a right triangle to solve for something. Is it going to happen very often that I'm going to make you do that? No. Could it happen? Yes. Okay, 2 times b being 6, plus p, which is 12 times, what is the height of this prism? Surface area will be 36 centimeters squared. Capital B was 6, height of prism we said was 2, the volume will be 12 centimeters. What? Cubed. A little further behind where I'd like to be, but we'll be okay. I do want to do the final problem. I do think it's going to help us. Greta, what shape is D? Hexagon. Hexagonal. What?
Prism.
Yes. Being a prism. Means we've got that formula and this formula. Being a hexagonal prism means the bases are hexagons. Like that one. And that one. So I draw my hexagon. What do we know about the hexagon? Can't call on people who aren't here. That last part was talking to myself. What do we know about this? Anything? Side length is 10. Are they all 10? Yeah, they've got these tick marks here that indicate they're all 10. If all the side lengths are the same, it's not just any old hexagon, it's what kind of a hexagon? Starts with an R, do you remember? Regular hexagon. That's important. Okay. What other measurement do we know about this? Not the height. We know the height of the overall prism, but what do we know about the hexagon? That's not height, but that's about the hexagon. That's 8.7. Not the radius. Radius would go to the corner. It might help if we decide what formula we use for the hexagon.
1/2 times A times S times N.
It's a regular polygon formula. 1/2 ASN for base area. One half times, what does the A stand for?
Area.
No, lowercase a.
Oh, apothem.
Apothem.
Why do I have mine written wrong?
I don't know. What's the length of the apothem? That's what that length is. 8.7 is the apothem. Side length we said was 10. N is number of sides. Number of sides on a hexagon is 6. Base area is 261. We didn't do perimeter. A regular hexagon, you can find the perimeter by doing the perimeter formula, or you can add up all the sides. But there's an actual formula for it for regular polygons. Side length times number of sides. Beyond that, it's the same process. But I wanted to show you a regular polygon one too. For the most part, the last bit of this, I'm just going to kind of quickly write in because I want to give you guys work time. And at this point, it's just plugging stuff in. The only thing that I still think we want to practice is what is the height of the prism? 7. Surface area ends up being 942.
Why is 7 the height on that prism?
Because it's distance from base to base.
Okay.
Perpendicularly, technically. Okay, surface areas have miles squared, and volumes have miles cubed. Okay, I have a worksheet for y'all. Now, I knew today was likely going to be one of the longest days of the unit. So, just as that forewarning, as we move forward, the lessons are going to get shorter. But also, it's got 8 problems.
It's gonna get harder. Right.
That's not what I said.
Oh.
I did not say it was going to get harder. Honestly, prisms tend to be the one that trips people up most. But we have to start with prisms because it is the basis of other things that we build. But I purposely have the worksheet. It's only 8 problems. Tomorrow, we will go through the bottom 2 problems on the notes packet. And then I got a worksheet for you that does the working backwards problems. That one is also short. In fact, it's shorter. But this is the longest of all the sections. So thank you for being awesome. I know, it's hard to focus this one.
Thank you. So, you okay if I take one lap real quick?
What is that? Can I look at that?